Okay, so let's go ahead and take a look at the second review packet. As we're working through this review packet, I want to encourage you to stop and pause the video at any time, either to make sure you understand what was just done, or to maybe try the next part of the problem. A lot of these problems you're going to see as we're working through this have multiple parts, A, B, C, D, etc. So maybe after I do parts A, maybe in part B as well, you might want to stop and see if you can try, for instance, C and D in problem number 1 on your own, and then hit play, see if you got it right or not. Okay? Alright, so let's take a look at number 1. So we've got all these different values from the unit circle, and they're asking us to give exact values. So all I'm going to do here is say, okay, what function am I talking about? Well, in this first one I'm talking about cosine. We know that cosine is our x value from the unit circle. And this is just asking us, what is the x value at 4 pi over 3? Well, the x value at 4 pi over 3 is just negative 1/2. Okay, simple, done. It's just a matter of memorizing. Sine of 5 pi over 6, that's the y value. So that is positive 1/2. The tangent is our y divided by x. So the tangent is actually the y value and the x value at 5 pi over 4 is exactly the same thing. So I'll write it out to show the work, but then you'll kind of see where I'm leading, where we're going with this. Okay, so the y value is negative square root of 2 over 2, and the same thing with the x value, negative square root of 2 over 2. When we simplify this, we get positive 1. So no need to plug all that mess into your calculator, just simply it's something divided by itself equals 1. Okay, moving on to probably the hardest and maybe the most trickiest. Secant. Well, secant is just a reciprocal of cosine, so that's 1 over the cosine of 11 pi over 6. So if we substitute in what the cosine of 11 pi over 6 is, we get 1 divided by square root of 3 over 2. We simplify this further. If we take 1 and multiply by the reciprocal of the square root of 3 over 2, we get 2 over the square root of 3. But we know that we're not allowed to leave a radical in the denominator. So after we rationalize this, we get 2 square roots of 3 over 3. Okay, let me go ahead and fix that real quick. Sorry, that was supposed to be a 3. Okay. Alright, so we have all 4 of our answers. Okay, moving on to number 2. Number 2, express the given angle in radians in terms of pi and as an approximation. So I basically want the calculator value as well as the exact value to give you a little bit of practice with that. So when we go from degrees to radians, we want to multiply our degree measure. I'll just call that x. So x degrees. We want to multiply that by pi over 180. So basically we're just taking each one of these values, 219, 152, and 339, and we're just simply multiplying that by pi over 180. So a little trick that I like to do on the calculator is that I don't include pi. I just simply plug in the numbers. So for instance, I'm going to plug in 219. I'm going to multiply that by 1 divided by 180. Again, I'm leaving out the pi. I'm going to tack on the pi at the very end. we get this decimal, but then I want an exact value, so I'm going to hit math to a fraction, and that'll give us 73 over 60. So our final answer for part A is 73 pi over 60. So I'm going to do the same thing with 152 degrees. (152) times 1 divided by 180. Change that to a fraction, and we get 38 over 45. So we have 38 pi over 38 pi over 45. And then we want to do 339 degrees as well. If we do the same exact method, we'll get a simplified answer as 113 pi over 60. And I'll also ask for the decimal approximations as well. So if we go into our calculator and just plug in 73 pi times 60, I'm sorry, 73 pi divided by 60, we get 3.82, so you can jot that down or check to see if you had the right answer. I'm also going to do 38 pi divided by 45, so you can jot that answer or see if you had the correct answer, 2.65. And our final approximation would be 113 pi divided by 60. So you can jot each one of those down as well, since the question did ask for in terms of pi and the approximation. Okay, so for number 3, really all you're asked to do here is just sketch a graph. So on our final, we're going to be able to identify these polar equations, and luckily we have our calculator to help us with that. So I'm going to first clear this out. I'm going to change the mode. Make sure your calculator is in radians. I'm also going to change the mode to polar, which makes sense because we're talking about a polar equation. I'm going to go y equals, I'm going to plug in part A, 2 cosine 2 theta. This is just a recommendation, but I would recommend that you go to Zoom, choose the option that says standard, so option 6 for my calculator, and you should see something begin the graph. Now, my graph's kind of small, so I'm going to zoom in a little bit. I hit zoom. Nice little trick, I'm going to use the Z box, which basically just lets you scroll in, or I'm sorry, zoom around only what you want to zoom around by dragging a little box. Kind of neat. Okay. So there you go. So if you're asked to sketch or identify the graphs, that's all you need to do. If you're asked to sketch it, just make sure that you label your x and y axis. So it looks like that this goes out to about 1, 2, and 1, 2 on the y axis as well. So you just want to fill that in. Okay. The same exact thing for part B. Should look something like this for cosine of 5 theta. Hit graph. Okay, so this one's a little bit bigger, so I want to use a zoom out feature this time. We go down to number 3, we hit enter, and then we hit enter again. It's going to zoom out for us. We get a pretty decent graph. So again, if you want to maybe just zoom around it, or go to your window and just kind of look at where you need to go to, I want to change my x-axis to about, I don't know, -5, and +5 in both directions, and maybe my y to, I don't know, +5 and -5 as well. Lots of different ways to control how we zoom in and out. So I said -5, positive 5, negative 5 again, and positive 5. Okay, graph, we should get a little bit better picture, so if we're asked to sketch it, we can be as accurate as possible. Okay? Alright, so let's move on to number 4. Number 4 says evaluate sine of 2 theta given the following conditions. So remember that there is a special formula for sine of 2 theta. So hint, hint, this might be something that's on your final. So it's definitely something to put on your cheat sheet. We have the sine of 2 theta equals 2 times the sine of regular theta, so basically without a number inside the parentheses here, times the cosine of theta. Okay, so we're going to use that again. So this is very similar to something that was on packet A. So I'm going to go ahead and draw the picture that represents this situation. So I'm going to, up here, I'm just going to make a little crosshair so I can identify what quadrant to put my triangle in. It says the sine is positive, so the sine again is your y value. So think, I'm sorry. So sine is your y value. So think, where's your sine value positive at? Well, the sine value is positive here and here. The cosine value is less than 0, so the cosine is your x value, and they're saying less than 0, so that's just another way of saying negative. Your x value is negative in the second and third quadrant. So that means that our triangle has to be in quadrant 2. So I'm going to draw a triangle in quadrant 2. It says sine, so that's opposite over hypotenuse, 24 over 25. We can use the Pythagorean theorem to figure out the other side. I know you guys know how to do that now. We get 7, but just a reminder that since we're going left on the graph, it will be a negative 7. Okay? It asks us to find the sine of 2 theta. So I'm going to right. Sine of 2 theta is equal to 2 sine of theta. Well, the sine of theta is just 24 over 25. We're actually given that in the above. And the cosine of theta, we need to figure out what the adjacent side was, which we already did, which was negative 7. And we're going to divide that by the hypotenuse, 25. If we do that in our head, or if we do it in our calculator, we get a final answer of negative 336 divided by 625. Okay, so again, like I said at the very beginning, I would maybe recommend that you pause and see if you can do part B on your own. Okay, so let's see how we did on part B. So here it tells us that the tangent is a positive value, so that means that the x and y have to be the same. Because again, tangent is y divided by x. So if we want a positive value, the y value and the x value have to be either positive, or they both have to be negative to get a positive value. So tangent is positive in the first and third quadrant. Sine is negative or less than 0 in the fourth and third quadrant. So our triangle this time is going to be in the third quadrant. Okay. So it says tangent is 3/4, so I'm going to go the opposite side and the adjacent side. But now, again, just a reminder that since we're in the fourth quadrant, this is negative as well as this is negative. Don't forget to use those because they could play a part in your final answer. Use the Pythagorean theorem. you get 5 for the hypotenuse. So then just plugging in like before, sine of 2 theta is equal to 2 times the sine and cosine. The sine is negative 3/5. Cosine is negative 4/5. And we get an answer of 24 over 25.